All right, good afternoon. Today we're going to be talking a little bit about the periodic table. Last class you guys read a little story, not really a little story, but a biography a little bit about this guy named Dmitri Mendeleev. And Mendeleev was the gentleman who kind of developed the idea of what is now our periodic table. Just so you guys know, when we say periodic table, what we mean is this kind of illustration right here. You guys will become very familiar with this over the course of the next few weeks. But when we talk about periodic table, this is the modern periodic table. And we're going to talk just a little bit right now about kind of how it's organized and how it came to be organized the way it is. So you read this little bit about Dmitri Mendeleev, and hopefully that gave you a background, and hopefully you appreciate a little bit about why it's so helpful that these elements are arranged. But anyways, what you guys have in your notes, and most of you guys printed your notes out. If you don't, or if you can't find your printed notes, then you can go back to last class date on the website, and you can download it again. And then I would say that you need to type your notes. The good thing about typing your notes is as long as you save it, you can't lose it. You can easily lose a piece of paper. So anyways, we're at the part in our notes that says Mendeleev in bold. There's nothing really for you to fill out here, so just listen for a moment. This is what it says. Follow along, please. Mendeleev is a Russian scientist. He wanted to arrange the known elements in a usable way. So he wants it to be usable. It shouldn't just be a random list of all of these different elements. So the things that he looked at were things like density, which is kind of like how heavy it is compared to how large it is. Like, if you've ever heard the joke, what weighs more, a pound of feathers or a pound of lead? The way that that works is that they both weigh the same amount. They both weigh a pound. But what's different about them is the fact that the lead might only be about this big, whereas the feathers would have to be, take up a much larger area in order to take up a pound. So what's different between them is the density. So elements each have their own characteristic density. Then we talk about things like color, at what point the elements melt. So the melting point, like with water, we know that ice melts at 32 degrees Fahrenheit or 0 degrees Celsius. There are other elements that are liquids or gases at room temperature, so they would have a much lower melting point. Other things we look at are things like atomic mass, which is just saying how heavy is one atom of this element, and also the number of chemical bonds. We won't talk too much about that. Number of chemical bonds just basically impacts how this particular element reacts with other elements. That's what number of chemical bonds is going to tell you, is how it reacts. So anyways, those are the characteristics that Mendeleev looked at in order to create his version of the periodic table. So you see in this little indent here, he arranged his table in order of increasing atomic mass and was able to predict the properties of undiscovered elements. And that's really, really amazing because by arranging it like this and looking for the patterns that he was looking for, he was kind of like cross-referencing and creating a grid, which is what you probably might compare this to is kind of like a grid. But he was able to actually predict the properties of those elements because he saw holes in the grid. He said, we don't have an element that fits here, that has this, range of atomic masses with these certain properties. So he was able to make some predictions, and it's really neat because eventually later on those predictions ended up being proven true because those elements were found. They fit the characteristics that Mendeleev had for them. Okay, so anyways, that's a little bit of the history of how the periodic table became developed. So what we're going to talk about now is the modern periodic table. Modern periodic table does have a few differences compared to Mendeleev's, but we're going to focus right now on what we can learn from the modern periodic table. First of all, what you'll see in the modern periodic table is just simply that you have this kind of grid where you have all these boxes, and each box is representing one element. Now, even though each box represents a different element, you're still going to notice that these boxes all have the same types of information in them. So if we look at just one box here, like if we look up at hydrogen, we see a lot of information about hydrogen. We see 4 pieces of information. And if you look to the side of your notes, you'll see what that information is. It's really kind of blurry on this one, but you'll see, and if you look in your notes, you'll see this. In your notes, the very top number, you see it's labeled the atomic number. If you remember from maybe 2 classes ago, we talked about the atomic number, and all that the atomic number is simply the number of protons in an atom. The number of protons is what decides what element it is. So it's really important that that number of protons is on the very top. So like in the example that you guys have, it says 26 for the atomic number. The next thing we have, and you can just follow along with this list here, I'm under where it says the modern periodic table includes the following information about each element. First thing, atomic number, check. Second thing, the element name. I figured that one didn't really need an instruction. But the element name is spelled out. It's under the big letters. But the element name, like for this green one right here, is hydrogen, and you can see that. The element name for the one on your notes is iron, and you can see that it says iron right there. The next thing we have here, it actually kind of has 2 names. Like in your little picture illustration, it says element symbol. It can also be called the chemical symbol. And the chemical symbol is just basically an abbreviation. The only rules for that abbreviation is that it's 1 or 2 letters long, and that the first letter of the abbreviation is always capitalized. Second letter, never capitalized. First letter, always capitalized. So we're going to write down the definition of the chemical symbols. Oh boy, that makes it so much easier than using tape. All right, remember, you've got the power of the pause. I'm not talking about cat paws. All right, chemical symbol is a 1 or 2 letter abbreviation for an element. I hope I spelled abbreviation right. The first letter is always capitalized in it. So please make sure you include all of this part, all of this definition in your notes. Remember, you have pause that you can press. That's on